All right. Uh, Hello, everyone. Good morning, good afternoon, or good evening. Dear authors and invited guests, welcome to Technical Session 3B, or 6B. My name is Alesha Mullah, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Congress on Information and Communication Technology, ICICT 2026 in London, UK. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in London, and the virtual event is being held through Zoom from 25th to 27th February. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for question and answer. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants to stay connected with us till the closing remarks.
फोन कॉल पे बात करता हूँ. हेलो, एक मिनट बात करता हूँ जरा. मैं फोन पे हूँ दूसरे.
All right. If you have any query or update, then you can write it to me in the chat box. Before we start the session, I would like to introduce you all to the chairs for this session. Dr. Shyam Akashe is a professor in Electronics and Communication Engineering Department and Dean International Cooperation and Projects at IIT University, Gwalior, India. He has been serving as a TPC member in IEEE and Springer conferences. His areas of interest in research are low-power VLSI design, modeling, FinFET-based memory design, circuits for future VLSI technology, digital design, and FPGA implementation. I request Dr. Akashe to please say a few words.
Hello, I'm audible, Anisha?
Yes, sir.
Yes. So once again, from this, all the participants, Dr. Albert, Alisha, and the GR Foundation. This side, Dr. Shyam Akashi, I'm professor and Dean International Corporation at ITM University, Gwalior. It is my great pleasure and honor to welcome to you in this technical session of the International Conference on Information and Communication Technology. So this is the 11th conference, and it will be served as an excellent global platform to researcher, academician, and industry professional to share their latest research finding, innovative ideas, and technology advancement in the field of information and communication technology. This conference plays a virtual role in forecasting, collaboration, and promoting high-quality research in the address of current technology and future challenges. My best wishes to all the participants. As per the remarks given by the Alisha, every authors, they have the 12 minutes, and in that 12 minutes, they can give the particularly the presentation, and there is a question answer sessions. So I will be take care, and Dr. Albert also available with me, and my best wishes to all the participants. Thank you very much. Thank you one and all.
Thank you, sir. We also have with us today Dr. Albert Kofi Kwanzaa Ansah. He is a senior lecturer and the vice dean of the School of Railways and Infrastructure Development, SRID, at the University of Mines and Technology, UMAT, in Tarkwa, Ghana. His research focuses on blockchain technology, cybersecurity, privacy preservation in cryptocurrencies, particularly Bitcoin, and computer network design. Dr. Ansah has authored numerous scholarly papers on threat detection in IoT, wireless power transfer, and user privacy in peer-to-peer payment systems, contributing significantly to secure and resilient digital infrastructures. I request Dr. Ansah to please say a few words.
Thank you very much. Good morning, good afternoon, good evening to you all. It's an honor to welcome you to the 11th International Congress on Information and Communication Technology. And I thank you all for joining, all participants for joining. We look forward to an insightful presentation and knowledge sharing and make the time worthwhile for us. I thank you all, and we look forward for a very, very beautiful presentation this afternoon, this morning, this evening. Thank you very much.
Thank you, sir. Now let's start with the papers. Our first paper for today is by V.L. Sindhuja. It's titled An Efficient and Secure Infrastructure as Code, IAC Automation, Framework and Security with DevOps. I request you to please start your presentation.
Hello, ma'am. Am I audible?
Yes, you are.
Yes, you are.
Uh, can I share my screen?
Yeah.
Okay. So is my screen visible? Hello?
Yes, it
Yes,
is.
please share your presentation first. Screen is visible, but the presentation is not visible. Yeah, now it's okay. Can you maximize it in the slideshow? Yes, very good. Yeah, please go ahead.
So good evening, everyone. I am V. Sindhuja from the Department of Computer Science and Engineering, and it is a privilege to present my research on a secure and infrastructure as a code automation framework with DevOps. To understand this research, we must first look at the massive shift in how we manage computing infrastructure. We have moved into the era of infrastructure as code. In the past, setting up a server required manual configurations that were slow and error prone. Today, we define hardware through machine readable definition files. This paradigm shift allows us to treat our servers like software where we can version them, test them, and also deploy them in seconds. However, this speed creates a massive security gap. If your code contains a single error, an insecure data center can be created in seconds. My research focuses on how to maintain the deployment speed while making the security bulletproof. Um, my key benefits and critical challenges include as outlined on this slide, the benefits are clear. Automated provisioning significantly reduces human error, and version control allows us to track every change or rollback if a mistake occurs. But these benefits come with critical challenges. The most dangerous of these is credential exposure. We often see developers accidentally leave API keys or passwords inside these code files, which are then committed to public repositories. Additionally, misconfigurations frequently lead to compliance violations that put an entire organization at risk. Our framework is designed specifically to bridge these gaps by integrating security directly into the automation pipeline. Uh, the core problem we identified is a fragmented tool ecosystem. Most organizations use disconnected tools that don't communicate, creating security blind spots. Furthermore, traditional compliance checks are often manual and slow. In a fast moving DevOps environment, these manual checks are frequently skipped to save time, resulting in infrastructure that violates security policies. Our research steps into automate these checks so they are good and mandatory so that they cannot be ignored. So, our research had five clear objectives. First is to enhance security posture by making security controls a part of entire life cycle. Second one is to automate compliance validation, ensuring code is checked against policies before it is deployed. We also set out to eliminate credential exposure through secure secrets management and to improve the overall reliability of these deployments. Finally, we wanted to make a framework that supports scalable DevOps, allowing multiple teams to deploy safely across different environments. So, this is the heart of our work, the secure ISC automation framework. Our architecture integrates security at every single stage. It begins when a developer pushes the code into the GitHub. This triggers Jenkins, which acts as the brain of the operation by starting the automated pipeline. Before any infrastructure is built, the code must pass through a security gate using tools like TFSec and CheckOV to validate this configuration. A key innovation here is HashCrop Vault, which supplies dynamic secrets so that passwords are never stored in the code. Finally, Terraform provisions the resources and Docker ensures consistent containerization. This ensures security is fundamental component of the workflow, not an afterthought. And these are the tools and technologies that are used in our project. And our methodology follows a strict automated four-step workflow. The first one is pipeline activation, which includes triggered automatically via webhooks. Security scanning. TFSec and Checkov perform static analysis to find hidden flaws or misconfigurations. And the third one is secret retrieval. HashiCorp Vault provides dynamic credentials through secure API calls, effectively eliminating hard-coded values. And fourth one is provisioning. Terraform only applies configuration after every security check has passed. This prevents dirty deploys from ever reaching the cloud. Next comes our security mechanisms. We have integrated multi-layered protection that focuses on automated compliance validation. We ensure that configurations meet industry standards like CIS and NIST before deployment. By using HashiCorp Vault, we provide automated rotation and encrypted storage for secrets. This DevSecOps integration means security is embedded throughout the deployment cycle or development cycle, preventing insecure developments from ever reaching the production. And our experiment results include we evaluated our proposed framework against traditional pipelines, and the results were significant. We achieved a 40% gain in compliance accuracy, meaning our framework was much more effective at detecting policy violations. We also saw a 35% reduction in credential exposure thanks to our secrets management integration, and a 30% improvement in development reliability. These metrics prove that adding security layers makes the entire system more stable and efficient. And the main advantage of our framework is the 70% reduction in manual intervention. This allows developers to move faster while maintaining rigorous security standards. Furthermore, our pre-deployment validation catches 85% of the configuration errors before they reach production, while significantly reduces downtime and infrastructure failures. Ultimately, this bridges the gap between speed and security, fostering a culture of shared responsibility. And looking forward, we plan to extend this framework to a multi-cloud deployment that supports AWS, Azure, and GCP simultaneously. We aim to integrate AI-based anomaly detection to predict potential security incidents. In conclusion, our research provides that security and automation are not mutually exclusive. By using intelligent tool integration, organizations can achieve both rapid deployment and robust security posture. Thank you for your time, and I'm now ready for your questions.
Yes, nice presentation. Can you please explain me what are the key feature of IAS? Hello?
Yes, sir.
Yeah.
Yes, sir. Yes.
What? Yeah, please.
Since our research is about making ISC secure, understanding its core features is essential. First one, I think declarative nature and idempotency and immutability, sir. And also, as we are using Git, it is used for version control also.
Okay, thank you.
Thank you, sir. Can I stop
Yes,
sharing my screen?
Yeah, just a minute. Yes, Dr. Albert, you have any question?
Yeah, please, I have no questions for now.
Yeah, please go ahead. Thank you. Thank you.
Thank you, sir. Thank you, ma'am.
All right, so our next presentation for today is by Heap LT, who will be presenting design and analysis of SPN-based block ciphers for secure communication systems. Heap, you may now start presenting. Is Heap or anyone of her co-authors present in the meeting? All right. In that case, we'll be moving on to the next presentation. The next presentation is by Miroslav Stefanov, who will be presenting Integrating Agentic AI with NIST Frameworks, KPI-driven detection and response improvements in security operations centers. You may now start your presentation.
Hello, can you hear me? Yes, no,
Yes, we can.
good, thank you. Now I share my screen. Good. Now share my presentation. Okay. Good afternoon. My name is Miroslav Stefanov. I am. Can you share?
Your screen is not visible.
Interesting. No. Again. Now you can see or no? No. Maybe just try something. No.
Yes, your screen is visible.
Good. Okay. Good afternoon. My name is Miroslav Stefanov. And yes, start my presentation. For to introduce myself, I am a cybersecurity researcher specializing in theory and practice in cyber security operations center. I build them AI-driven security architecture in incident response. I'm currently PhD student, University of Library Studies in Information Technology in Bulgaria, under the supervision of Professor Stoyan Denchev. Now I'm professor at Embry-Riddle Aeronautical University in US, Florida. Today, I present our research integrating agentic AI with NIST, National Institute of Standardization of Technology, frameworks to achieve measurable key performance indicator KPI-driven improvement in Security Operations Center, SOC, detection and response. The focus is KPIs operational, false alarm rate, time to detect, time to respond, and SLA, service level agreement compliance. Most security operations center already use SIEM, security information and event management, and SOAR, security architecture, automation and response, and machine learning models, of course. The real issue in the SOC environment is that model outputs are not linked to measurable KPIs, and those KPIs are not aligned with the regulatory NIST phases. Result, slow detection, slow response, and stable SLA. We addresses this structural gap. Current ML-driven SOC searchers focus on AUC and F1 score. Operational KPIs like mean time to detect, time to respond, and SLA are not integrated, thresholds are not cost-aware, and there is no explicit NIST mapping. The gap is the absence of unified architecture linked detection to regulatory compliance. We propose an integrated agentic AI architecture to close it. Research question: can an integrated agency AI architecture significantly improve operational SOC KPIs compare a baseline while remaining aligned with NIST frameworks? Hypothesis 1. Agentic automation reduce false positive and negatives as well as time to detect and respond compared to the baseline architecture. Hypothesis 2. Probably calibration and cost-sensitive thresholds improve SLA hit rate in operation predictable. Both hypotheses must be statistically validated. Novel contribution in this direction, in three directions. First is normative, direct mapping to NIST 800 and cybersecurity framework 2.0 with full traceability. Second is architecture, transition from static rule to governed decision flow with policy engine, calibration, guard released in human in that loop. This is our agentic ODA model. Observe, decide, act with governance. Observe, monitoring, again, agents, computer KPIs, compute KPIs and AG bulls generate attacks probabilities. Second is decide, the police engine application calibrated probabilities in cost-aware thresholds supported by guard release in human validation. Act, sort, executes response, and LightGBM predicts main time to respond in recovery. Governance ensures its audit, logging, traceability, KPI monitoring, and SL tracking. Model generate prediction, agents decide and act within a governed operational framework. This slide shows how our architecture can connect agent, model, KPIs in regulatory frameworks. On the left, you have 10 agents for attack detection, traffic monitoring, decision control, time prediction, action, automation, etc. We use machine learning algorithm XGB boost to detection and LightGBM to response time prediction. We use deep learning model BERT for text analysis. These models directly influence the 6 operation KPIs. We use false positive and negative, main time to detect to respond to recovery in SLA hit rate. Each measurable KPI maps to regulatory needs phase, detect, respond, and recovery. This is full traceability from prediction to compliance. Our methodology combines multiple dataset models and validation layers. Primary dataset CCDS 2017 for training and validation of XGB boots detection and LightGBM mean time to respond to recovery. Second database is IDS 2018 and CTU 13 for cross-data robustness testing. Next, you have use for board training STR review for SL sign enrichment. Operation validation you did with Vezuh, SoftHelp for KPI benchmark and SL verification. Ensure statistical validity in operational realism. How single incident in process in our architecture. You have XG boosts generate raw probability, plot calibration improves reliability, cost-aware threshold applied, policy engine evaluates result, operational action executed. We evaluated 3 calibration methods: Platsky link, isotonic regression, and temperature scaling. Platsky link was selected from test because lowest calibration error, stable probabilities not performs lost. The experimental design follows 5 structure steps. First is time block evaluation, where data is split chronologically. Second is ablation, removing calibration in crossware thresholds. Third is latency and throughput operation benchmark, stress test of SL benchmark. In 5 drift analysis showing online updating stabilization performance over time. Detection performance reached AUC of 0.957 in an F1 score of 0.869 result in 62.8 faster detection, 38% faster response, and 38% prediction in incorrect automated actions. At the discovery level, we analyze KPIs to understand the decision made by the model, feature contribution analysis, or real correct attack detection, missed attacks, and normal traffic cases. True positive shows strong concentrated signals, false negative shows weak or overlapping patterns, true negative shows stable uniform profiles. Detection decisions are explainable in misclassification or analyzable rather than random. Beyond detection layer, but attention weights identify escalation terms, support human validation in ambiguous cases. Governance logging, KPI SL compliance, regulatory alignment ensure traceability and control automation. Operational acceleration is statistically validated. Hypothesis once validated from agentic automation significantly improves classification performance and accelerating on observed decide cycle. Hypothesis 2 is confirmed from probability calibration and crossword thresholds improve SL performance and operational predictability. Agency architecture delivers measurable detection accuracy, reduce response time, increase SL compliance, regulatory alignment. This is governance SOC reducing with full reliability. This architecture is designed to be integrated into real SOC. You try that, like managed security service providers, critical infrastructure, financial institution, regulated public sector organization, delivering KPI-driven governance, reduces operational risk, optimize analysis workloads, and improve scalability and connection regulator alignment. Thank you. This was stop sharing.
Yes, very good presentations. Thank you very much, sir. You have given a very good presentation, and this is the latest trend in today's era. So my question is that, as you mentioned about that, the agentic AI using from SOC, so how agentic AI improves SOC automation?
OSI2 automation.
Yeah.
This was maybe long time between 6-8 months long period to training this model. We try different agentic to how to set them to work this agentic together. And this maybe we involve a lot of people, students, to help about that. You of course you set everything in our servers to train this model. Alert score, fixed threshold, auto respond, alert score, celebrate probability policy engine, cost-aware SL aware in guidelines, audio, escalate block governance logging. We improve few false positive and negative. I told you use real SOC because before that I was part from the where built National Security Operations Center in Bulgaria. Of course, you have a lot of data. We can train this model in this agentic.
Oh, yes, I'm very happy for such a wonderful topic you have chosen, and this is the current trend, and the future is also from upcoming 5 years to totally work from these topics. And my best wishes to you. Thank you very much.
Thank you.
Thank you.
I have a question here for him. Thank you very much for such an elaborate presentation, sir. I want to ask that which KPIs are your framework actually optimizing, and how do agents improve detection of that KPIs?
I shall use 5 real KPIs, but our works shows that everything is good about this KPIs, whereas false positive and false negative. You know this formula, whereas for negatives, false positive, how to be faster in of courses will be correctly, and not just faster. This KPI, of course, this time where time to detect and respond, this time was shortly. For us, because in real work, when you work in the cybersecurity center, you have different issues, different choices, which is correct, which is not. But when I work in different security operation center, nobody have a manager. I talk about the managers don't have interest about KPIs. They just see SOC work or not, everything is good, but nobody see about these KPIs, that these KPIs show that this security operation center is good, because you have to learn to give more clients, but nobody interested about that. Interesting about this research was this SLA hit rate, because you use when some clients is okay or not, you send different questions in our clients and ask them what mean about our SOC. Maybe you collect 5 SOCs, different clients, and he suggests to try this BERT algorithm model, how to see which is good for client and what is not good for client, and what is correct. How I say, what is correct, how SOC is work about this client.
Okay. I hope Dr. Albert is satisfied your answer.
Yes, please. Thank you.
Yeah, please. Thank you. Thank you very much. I request to the participant, please take the time constraints. It is not more than 12 minutes.
Of course. Let's move on to the next participant. Next, we have Askarova Makhabbat Ibrahimovna, who will be presenting her paper on migration policy effectiveness in Uzbekistan, a digital governance perspective. You may now begin your presentation.
Alisha, I think not available, so.
Right, of course. Are any of the co-authors of Askarova available in the meeting? All right. Okay. In that case, we'll move on to the next presentation. So next up, we have Heap LT, if she is in the meeting now again, we can continue. All right, seeing that I don't see her in the participant list, we move on to the next.
Maybe she is not available, I think so.
Right.
Yeah.
So our next presenter is Rakhmanova Nargiza Rashidovna, who will be presenting her paper, Ways to Further Improve the Efficiency of Road Border Custom Posts in Facilitating Foreign Trade Using Digitalization. You may now begin your presentation.
Is it not available?
If any of the participants who have missed their presentations earlier would like to present right now, they can write to me in the chat box. Yes, we'll be waiting for another 2 minutes just in case anybody wants to present.
Yeah, please. We are waiting for that. No problem.
Hello?
Yeah, someone is available, I think so.
Yes, you may continue.
Hear me?
Yeah, we can hear you.
You can hear me, yes. It was some problems with the voice, with microphone, I mean.
No problem, no problem.
Oscar.
You please go ahead. No problem, you please go ahead. Go ahead.
Okay. A second, please. I'll demonstrate my presentation right now. Could you see it? Is it visible for you or no?
No, not
yet?
visible.
Not,
I think
not
you are
visible.
not shared presentation.
Yes, I'll share it. I'm
Yeah,
trying
please.
to do it. Okay.
Yeah, please go ahead. Go ahead.
Wait. I couldn't. Maybe. Yes, this one. Okay. Is it visible for you?
Yes.
Could you see
Make it in
Yes.
slideshow.
Yes,
Yeah.
we
It's
can
visible.
see.
Fantastic. Yeah, fantastic. You please be, but please be convert into the slideshow mode if possible.
Good evening. Today I'll present research on migration policy effectiveness in Uzbekistan. The presentation called Migration Policy Effectiveness in Uzbekistan, a Digital Governance Perspective. International labor migration has become a key socioeconomic factor for Uzbekistan. Between 2 and 3 million Uzbek citizens work abroad annually, and remittances significantly contribute to household income and poverty reduction. Since 2017, Uzbekistan has implemented major institutional and digital reforms aimed at modernizing immigration governance. This makes the period 2017 and 2024 particularly important for evaluating policy effectiveness. Labor migration functions as a long-term income strategy for many households. However, it also creates structural challenges such as skills mismatch, irregular migration, and limited reintegration opportunities for returnees. Historically, immigration governance in Uzbekistan was fragmented and paper-based. After 2017, reforms focused on institutional restructuring and digital transformation in public administration, including migration services. The main aim of this study is to evaluate the effectiveness of Uzbekistan's migration policy through the lens of digital governance. In this research, effectiveness is understood not only in quantitative terms, such as increasing the number of registered migrants, but also in qualitative terms, including transparency, accessibility of services, protection mechanisms, and policy coordination. The study uses a mixed method methods approach. First, it includes qualitative analysis of migration laws, institutional reforms, and policy strategies implemented between 2017 and 2024. Second, it draws on official migration statistics from national institutions and international organizations. Key indicators include the expansion of legal migration channels, digital platform usage, skills composition of migrants, and reintegration outcomes. Since 2017, several major reforms have been implemented. This includes restructuring of migration institutions, expansion of bilateral labor agreements, introduction of pre-departure training programs, and development of digital platforms for registration and job matching. Reintegration centers were also established to support returning migrants. Empirical data show that the number of digital workers increased from 1.7 million in 2012 to 3.4 million in 2023, with significant growth after 2017. Digitalization improved transparency and reduced administrative barriers. However, more than 65% of migrants remain low-skilled. Skills recognition systems are still weak. Digital certification platforms are fragmented, and reintegration programs cover only a limited share of returnees. In conclusion, Uzbekistan's migration policy has become more structured and digitally advanced. Institutional reforms and digital governance have strengthened legal migration pathways. However, policy effectiveness remains uneven. To improve outcomes, Uzbekistan should develop an integrated digital migration ecosystem, introduce internationally recognized skill certification, strengthen reintegration systems, and enhance protection mechanisms for migrant workers abroad. Only a fully integrated digital and institutional framework can ensure sustainable and inclusive migration governance. This is the end of my presentation.
Okay. Thank you very much. Thank you very much. Yes, Dr. Albert, do you have any question?
Yes, something small here. Thank you for your presentation. Very clear. I want to just ask what outcome define the effectiveness, as you have stated. Is it the labor matching, remittance flow, or what? What actually defines your effective in terms of migration policy in your research? Thank you.
The outcome that labor matching as more skilled laborers are demandable worldwide. Labor's skills should match the working demands. So our research has effective outcomes that as could create methods to make it more to the implementation of the labor matching more effectively, and
All right, I think it's fine.
Okay,
It's fine.
no problem.
Thank you.
Thank you very much. Okay.
Okay, thank you.
All right. So our next presentation will be by Rakhmanova Nargiza Rashidovna, who will be presenting her paper, Ways to Further Improve the Efficiency of Road Border Customs Post in Facilitating Foreign Trade Using Digitalization. You may now start your presentation.
Good day. Can you hear me?
Yes, we can hear
Yes,
you.
Yes, we
you
can
are
hear
audible.
you.
You're audible. So please share your screen.
Sorry, just before you start, I would like to request the previous presenter to stop sharing their screen.
Oh. Huh?
All right, you may
All right.
begin.
Yeah. Now can you please unmute yourself?
I'm so sorry. Just
Yeah,
a
no
minute.
problem. Please. Yeah, please.
I cannot connect. I cannot connect from my computer. Just a minute.
Okay. No problem.
Good day. My name is Nargiza, and I represent the Customs Institute and the Customs Committee of Republic of Uzbekistan. Today, I will present an empirical study on improving the efficiency of customs posts at Uzbekistan road border through digitalization.
Yeah, please continue. No problems.
Excuse me, in case your laptop isn't working, you could send me your presentation in the chat box and I can present it for you.
I cannot send you my presentation. There are not connection with my notebook. Can I continue after next?
All right, yeah, no worries. We'll call on you after. Just give me 1 second. All right. In the meantime, we'll have Yi Chen presenting her paper on synthetic data generation to accelerate early-stage materials damage analysis in mechanical engineering. You may now start your presentation.
Okay, I'll share my screen. Did you see my screen now?
Yes, we can.
Hi everyone. I'll introduce my paper called Synthetic Data Generation to Accelerate Early Stage Material Damage Analysis in Mechanical Engineering. My presentation today is in 5 parts: motivation, problem definition, proposed methodology experiments, and conclusion. So nowadays, the global demand for automobiles is increasing, and this lead to a significant rise in carbon emissions. To solve this problem, several solutions have been proposed, such as the green energy vehicle and also repairing and reusing automobiles components. However, if the mechanical engineers they want to repair or reuse automobile component, they should determine the optimal time for the repair or the replacement. So it requires an accurate assessment of the damage level of the components. At this point, the machine learning models can be adopted to analyze the damage levels of the components. However, if we want to use the machine learning models, we usually require high quality training data to improve the performance of the models. But the traditional way to collect data in mechanical engineering is subjecting the components to different levels of damage and then using techniques such as the XRD to detect internal structural changes. So especially at the early stage, we don't have we don't have enough data for training a machine learning model, and it limits the early stage analysis of machine learning. So the synthetic data generation offers a promising solution. We usually use the two kinds of models to generate synthetic data, such as the variational autoencoder, and another one is the most common one is the generative adversary network. But several challenges remain when we apply GAN's model to generate synthetic data. A common issue is the instability of the GAN training. And at the same time, the damage levels of the components are predefined by engineers, and it requires that the generated data align with the specific labels. In addition, the quality of synthetic data evaluation is challenging since the distribution of real data is often unknown, so it's difficult to quantify how well the synthetic data approximate the real data. To solve this problem, we propose a methodology for generating synthetic data in mechanical engineering. It contains three parts: the data pre-processing, model development, and the evaluation. I will introduce each part in the following slides. So for the data pre-processing, it's a little bit simple. We just use the standard scaler to standardize the features and then transform the labels into one-hot encoded vectors. At the same time, the one-hot encoded labels are incorporated as conditional inputs to the generative model, making to produce synthetic data corresponding to the specific damage levels. Then for the models, we have two main components, the generator and discriminator. The goal of generator is to create some synthetic data with the input of the random noise. Then the discriminator aims to distinguish whether the data is from the real data or from the synthetic data. Then they both update their weights based on the generator loss and the discriminator loss separately. At the same time, the conditional input is passed to both generator and discriminator. So when the generator creates data, it should also create the data that meets this condition, as well as for the discriminator, its goal is in two parts. The first goal is to distinguish the data is from real or not, and then the second goal is to check if the generated data meets this condition. Finally, for the evaluation part, we evaluate two aspects of the synthetic data: the diversity and the fidelity. So for the diversity, we check the statistical characteristics of the synthetic data, such as the mean and also the standard deviation, to analyze the distributional characteristic of the generated samples. Then for the fidelity is the most important one. We use machine learning classifiers to compare the behavior of the synthetic data and the real data to check if the synthetic data can support the downstream model. Then for the experiments, the data set we have is a little bit small. It's around only 30 to 40 samples. And for each sample, we have 19 columns, including 18 features from the XRD measurements and one target label representing the damage level. And this target label comprises 10 discrete damage levels ranging from 0% to 90%. This is the statistical comparison for the synthetic data. The top two graphs are the mean of each features, and this is the standard deviation, and thus mean and standard deviation values of a real data and synthetic data are close aligned across most features. Then for the fidelity evaluation results, we train a classifier on the real data set and test it on the both real and synthetic data sets to perform a comparison. Here are the results. The left table are the results of real data test set, and the right table are the results of synthetic data test set. Although the results are not good since they are all around 0.3, this is still a meaningful tool for evaluating the quality of synthetic data since we just want to compare their performance among these two data sets. So we can find in both real data test set and the synthetic data test set, the model performs the best in the 90% damage level, since this is maybe because the characteristic of 90% damage level data, they are more easier to be captured by the model. And also maybe in 20% or 30% damage, and also the 50, 60, 70% damage, those two data sets performance are similar. So for the conclusion, in this paper, we present a framework for synthetic data generation and evaluation, and it contains three parts: the data preparation, data generation, and evaluation. The evaluation results show that our generated data closely resemble the real data in both aspects, and the synthetic data can therefore support downstream tasks, particularly in scenarios where the experimental data is limited. Then in the future, we will improve the quality of the synthetic data and also the real data as we have more training data. So that's my presentation. Thanks for your listening. If you have any questions, I'm here to answer.
Thank you very much.
Thank you.
Yes, can I ask a question?
Yeah, please.
Yes, just a quick one. In your research, I want to understand, I want to know, how do synthetic samples preserve the real failure modes? How does this? Yes.
You mean how can we define it the sample is failure, right?
Yes, that's correct.
Yeah, this is the task for the mechanical team, and they just induce the damage on the sample then until it is split into two parts. So that means the sample is failure and it's 100 damage. 100 damage, 100% damage.
Oh, okay. So in that case, how do you, what metrics actually ties the synthetic fidelity when it comes to engineering risk?
So sorry?
Did you understand? So what metrics ties synthetic, from what you have said, what metrics are used to decide the engineering risk in the synthetic materials? How can you, determine the risk factors? What factors do you use to determine the risk factors when you are using synthetic materials?
We don't use the synthetic materials. We just created synthetic data based on the real data we have. So we don't have synthetic material. And for the real material, the real sample, they use a XRD device to measure the internal structural some parameters to show the internal changes of the sample. So they use the XRD device, which is in the mechanical engineering domain, to test the internal structure of the sample and use the parameters we got from the device.
That's very well answered. Thank you.
Thank you.
All right. Nargiza, are you able to present now? All right.
I think she shared the presentation in the chat box.
She has, but I think she's also joined from her laptop. So in case that's working, we can go ahead.
Yeah, please. Oh, yes. Thank God.
You're on mute.
Please, Nargiza, please unmute yourself. Please unmute.
Can you repeat?
Now it is, please go ahead. Now it is okay.
Can I continue?
Yeah, please.
International trade growth has increased pressure on
Nargisa, please turn up the volume of your laptop and then you can speak from your phone. There'll be no echo in that case. Nargisa, could you please unmute?
Yes, the presenter should unmute himself.
Presentation is going on, sir, but voice is not available. Nargiza, please unmute yourself. Now it's okay.
Can I continue?
Yeah, please continue.
estimation first from Russian resources to make this predictor of performance. Estimate the standardized coefficients confirm the dominance of human time. Strongest indicator demonstrates strong statistical validity. Standardized this visual model illustrates the relative strength of each aspect. This visual model illustrates the relative strength of each factor. The strongest path is steering from human.
Nargisa, would you like me to present on your behalf? Nargisa, can you see my screen? If you're there in the meet and you would like to continue, you can start with your presentation. I'll switch the slides for you. All right, I believe that's not working out. Just 1 second. All right, we'll be moving on to the closing remarks. So I sincerely thank all of our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope the session was informative, and we apologize for any issues that might have occurred during the session. On behalf of the whole team, I thank you for your support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters will be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the ICICT team. I also would like to thank our session chairs, Dr. Albert Kofi Kwanza Ansa and Dr. Sham Akashe. We have a token of our appreciation for you. So we would like to present this token of appreciation to the chairs on behalf of Team ICICT 2026 and Global Knowledge Research Foundation and partners.
Thank you.
Thank you for your valuable presence.
Thank you.
All right. So before we conclude, I would just request everyone to turn on the cameras so we can have a virtual snapshot. All right. Thank you so much, everyone. Stay safe and take care. The session is now adjourned.
Thank you.
Thank you.
Alicia.
Thank you.
Thank you, Albert sir.
Thank you.
Please keep it. Thank you, Albert sir. Please keep in touch.
I will. Thank you very much, Prof.
Thank you. Thank you. Please. Okay.